Hey there! Let's step into the shoes of our farmer friends for a moment. It's a typical day and we need to water the crops. We check the clouds, feel the humidity, and guess how much water the crops might need. But wouldn't it be awesome if there was an app that could do all of this for us? Well, guess what? Enter IndoreCropWaterWise, a smart AI driven solution that takes the guesswork out of irrigation with just a little bit of weather data for farmers in Indore. Let's dive in. Okay, so welcome to the app. This is the introduction page, and this is basically for all of you guys and for all of the first timers who are going to forget what I'm about to just tell. Don't you worry, I've got you. It will walk you through every single thing you need to access the app, and it's basically a very user-friendly app that requires minimal work from your end. So you can just give this a read through, a very brief read through, and you'll get how the app works. Okay, so that was the introduction page. And now this app basically has two pages. This is the main page of the app where we'll be calculating the accurate irrigation requirement for the crop. So the first step for the app is that we need to choose the crop type. So you have 6 crop types available, and these have been chosen based on the most common crop types that are grown in Indore. So suppose I go forth with cotton, and then you can just simply choose the growth stage of your crop. So let's suppose that we've just planted the crop, so it's in its initial growth stage. Then we've got to select some additional data for the irrigation calculation. So the first is basically the type of irrigation that you're using for your crops. So you have the option of drip, sprinkler, and surface. So let's suppose that my crops are being irrigated by drip irrigation. And then we need to enter the estimated rain for today. So before we do that, let's just have a look at all of the forecasted weather data for tomorrow. So we'll basically be predicting the irrigation requirement for the crop which was cotton at its initial stage for tomorrow. So the mean temperature is 26 degrees, maximum, minimum. We've got the wind speed, relative humidity, surface pressure, and then the estimated rain. And this data is very commonly available, and you can source it from any accurate website on the internet. So once you've gotten this data, and because I have access to all of this data, let's see, the estimated rain is 42.5 millimeters. So I'll just enter that. 40. Okay, so now that we've entered the estimated rain, we'll now have to choose the weather combinations that we'll be using to predict the ETO. So there are essentially 3 weather factor combinations that you can use to predict the irrigation requirement for your crop, and they are mean, maximum, and minimum temperature, which is the first combination. The second is mean, maximum, minimum with the add-on of wind speed, and then the third just has relative humidity and surface pressure added on from the second combination. And the thing with this is that as you increase the number of factors used to predict the irrigation requirement, the accuracy of the irrigation requirement predicted will increase. But obviously combination 1, which has the least accuracy of the 3, provides predictions that are good enough to work with. So even if you don't have access to other data, you can work with it. And then there's obviously combination 2 with just an additional add-on of wind speed, which is again very commonly available. So you can just use that, and then that provides a very good accuracy to the irrigation requirements, and it's almost comparable to the accuracy of combination 3. So now that we've understood the 3 weather combinations, let's go back to the main page. I'll just have to. And now, because I have access to all of the data for combination 3, which will provide the most accurate prediction, I'll be choosing that combination. And so basically I'll just select all of the weather factors from here. And also another important thing to note is that if you choose an incorrect combination and then click on OK, so basically nothing will happen. So you need to choose the correct combination, but the order of choosing the weather factors is not that important. You just need to choose the correct combination. So I've gone forth with combination 3. Let's click on OK. And now it's basically giving me the option to enter all of the data. So I'll just enter all of that from this document. I'll copy it from here. So now that we've entered the values, and sorry, actually I made an error. That was not 42.5 millimeters for tomorrow. It was actually 4.25 millimeters. So I've made that correction here, and now I'll click on calculate. So the model will run. Oh, and it's giving this output that it will be adequately irrigated. So basically, when the amount of rain that the crop will receive is going to be greater than the amount of water that the crop will lose, you'll basically get this output. And to understand this better, we can basically have a look at these intermediate values. So what we find here is that the evapotranspiration that's occurring from the crop is of 1.58 millimeters, while the effective precipitation, that's the amount of rain that's actually available to the crop that was calculated behind the scenes, is 3.83 millimeters per day. And hence the plant has all the water that it needs. It will receive all the water that it needs through precipitation only, and hence there isn't any need of irrigation in this scenario. Therefore, we're getting a net irrigation requirement that is negative, and the final gross irrigation requirement that's calculated by adjusting for the irrigation inefficiency or efficiency, you could say. That's the reason why we've asked for the irrigation type here. That's also going to be negative, and in such cases the app is just programmed to simply give this output. But if the precipitation would have been lesser than the crop water requirement that would have been predicted, then the net irrigation requirement and the gross irrigation requirement would have been positive, and then that would have been output to the user. And so you see just how easily we were able to calculate the irrigation requirements for the crop with such great accuracy. So this was all that there was to my app, and I hope you enjoyed it, and thank you for watching till the end.